Welcome to my projectbazaar.com. Now we discuss about the product word spotting and recognition with embedded attributes. Now we discuss about the abstract. This process addresses the problem of word spotting and word recognition on images. In word spotting, the goal is to find all the instances of the query word in the dataset of images. In recognition, the goal is to resize and recognize the content of the word in the image, usually aided by the directory or dictionary of an lexicon. We describe an approach in which both word images and text string are embedded in the common vectorial subspace. This is achieved by the combination of label embedding and attributes learning and common subspace regression. In this process, images and strings that represent the same word are close together, allowing one of the cost recognition and retrieval task or nearest neighbor problem. The most existing methods, our representation as an fixed length is low dimensional and is very fast to compute and especially to compare. We test our approach on 4 public datasets on land document images, and the images shows the better result than the state of art on word spotting and recognition process. Now we discuss about the flow diagram. At first, the input image is taken from the dataset image. Then the preprocessing step is done after the input image. The preprocessing is nothing but the image is converted into an binary format. In the binary format, the image have only the two values that have contains an zeros and ones. The 0 represent the black area and 1 represent the white area. After the pre-processing, the segmentation is carried out. In the segmentation part, we applied the bounding box for the segmentation. Bounding box is nothing but the box which is overlay for the each and every letter present in the word. After applying the bounding box, the area of the bounding box is cropped using the cropping tool. Then we use the feature extraction method for the segmented image. The feature extraction is carried out using the Gabor feature extraction method. In Gabor feature extraction method, we have gotten several values which is obtained from the feature extraction. After extracting the feature from the image, we have to classify the image using the classifier KNN. KNN is abbreviated as an K nearest neighbor. Using that classifier, we have to classify the train feature and the test feature obtained from the dataset. Then the recognized word comes out as an template format. The template format is obtained using the printed character letter. At the overall process, the input is taken from any handwritten image, or otherwise the input image is taken from the land document. Then the output will comes like an text, or output will be comes as an template format. So the template is the printed character. So the handwritten image will be converted as an recognized template format. Here the two algorithm, Gabor feature extraction and KNN classifier, gives the better result for the recognition process. Now we discuss the initial running procedure for the process. Select the main_GUI.m file, then right click on that file and select the third option, run. Now the initial GUI window was opened. In that we can see the several buttons. First one is input image, then pre-processing, then bounding box segmentation, then split character. These four buttons are represented as an push buttons. Then below that we can see the four axes. These are represented as an axis. Now click the button input image. Now the dataset folder will be open. Select any one word from the dataset folder and then click the open. Now the input image will be displayed in the axis 1. After the image displayed in the axis, we have to click the button pre-processing. After clicking the pre-processing, the simple image is converted into an binary image. The black areas are represented as an 0 and the white areas are represented as an white areas ones, so that the image contains the only two values such as the zeros and ones. Then the bounding box is applied for the binary image, so that we can click the button bounding box. After clicking the button bounding box, we can see the bounding box for each and every letter present in the image. Then we have to split the each and every letter present in the word. So first click the split character button. Now the four letters are splitted separately. Then click the button next. Now another GUI window will be opened. This is an second GUI window. In that we can see the feature extraction and test feature, train feature and recognition part. Now click the button feature extraction. After clicking the feature extraction, the feature for separate letters are shown. These features are the Geber feature, which is extracted for each and every letter in the image. After the completion of feature extraction part, we can see the test feature, which is for each and every letter in the word. We have 4 letters in the word, so the 4 feature extraction for the test feature. Then the train feature will be displayed in the another table. Then click the button recognition. After clicking the button recognition, we can see the template format of the recognized word.